Plarion are a scientific engineering company specializing in organic and inorganic thin films, in nanoreplication and in microprinting. The replication of surface features may be achieved accurately, quickly and cheaply by thermal injection molding. Materials that can be molded in this way are generally thermoplastic polymers such as polycarbonate, polypropylene, Zeonor and PMMA. Feature sizes may be less than 30 nanometers, with a reproduction accuracy of 1 nanometer, a cycle time of a few seconds and a cost as low as a few pence. Alternatively, for low-volume prototyping we may replicate the same feature sizes as by the previous injection molding process, but into a UV curable lacquer using a UV nanopress. First, we spin coat a thick layer of the liquid lacquer material onto a circular substrate, and when we say thick we mean of the order of 100 microns. The thickness of spin-coated liquids may be controlled to less than a micron using an accurate spin speed profile. A stamper is introduced under vacuum into the liquid film, which is then exposed to a UV flash lamp to cure the lacquer and achieve the replication. The 9-chamber vacuum sputter coater at Plarion operates in both DC and RF modes and can deposit up to 30 layers without breaking vacuum. Layers may be as thin as a few nanometers, in a wide range of materials including metals, dielectrics and chalcogenides. In reactive sputtering, a gas is introduced into the vacuum chamber, leading to the deposition of, for example, oxides or nitrides of the target material. One of the target positions in the coater holds an array of 4 distinct materials, which can be co-sputtered into a single layer. This allows the deposition of combination layers, or the creation of alloys in situ. For the deposition of organic thin films, a spin coating machine, originally used for CDR production, can coat thin films of organic, solvent-soluble material with a nanometer accuracy similar to that of the vacuum coater, all controlled by a versatile spin program and dispense control. The vacuum lamination station allows for the lamination of molded substrates or of thin films onto substrates by the use of a pressure-sensitive adhesive or simply by the application of pressure under evacuation. We can characterize the thin films deposited by means of ellipsometry, which measures the thickness and the optical properties of the layers. By measuring at a fixed frequency, a single dielectric layer may be characterized, or multi-layer films may be analyzed by spectroscopic or white light ellipsometry. We have a well-equipped chemical laboratory for sample preparation and for the spectrophotometric analysis of materials, for optical scanning, gas chromatography and other standard laboratory techniques. In our environmental chamber, we can create simulated aging by controlled cycling of temperature and humidity. This, in combination with modelling software, allows detailed reliability analysis and accurate lifetime prediction for a wide range of components. As part of our metrology suite, the Atomic Force Microscope, or AFM, works in tapping mode to allow nanometer resolution surface roughness analysis, or surface profiling. In conductive mode, it can detect impurities by conductivity variation on the same scale. A DECTAC profilometer measures surface profiles in the range of 100 nanometers up to hundreds of microns, which, when used in conjunction with the AFM, gives a surface profile measurement range of 6 orders of magnitude. Our optical microscopes include standard bright field mode, dark field mode for examining biological samples and subtle surface defects, and oil immersion mode for increased resolution. Our scanning electron microscope incorporates an EDX mode facility for the analysis of the atomic composition of a sample. PulseTech testers are advanced optical disc testers for characterization of the standard parameters associated with DVD and Blu-ray discs. Plarion have developed a novel microprinting technique using the laser from the optical head of a DVD drive, which allows us to print spots of material 200 to 400 nanometers in size with a positional accuracy of 100 to 150 nanometers. The materials that we can print by this technique include organic and biological materials. We are seeking novel application areas in which to exploit the capabilities provided by our in-house technologies and experienced personnel.